Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing a concept of how to analyze the shear force and bending moment for a cantilever beam when it is subjected to the concentrated load at its free end. Now I am just considering a cantilever beam AB of span equal to L, which is fixed at A and free at B and carrying the load of magnitude equal to W at its free end B. Now Fx represents the shear force at X and Mx represents the bending moment at X. So I have just taken a section X, that is capital X, which is at the distance of small x from the free end. Now I am just considering the right hand side portion of the section. So here the shear force of this section is equal to resultant force which is acting on right hand side portion of the given section. So but the resultant force which is acting on the right side portion of the section is W and which is acting in the downward direction. So as per our sign convention, the right hand portion of the section with the downward direction of the force is considered to be as positive. So therefore shear force at section X is considered to be as positive. So I just repeat it. So I have taken a section X. This is a section X. In order to calculate the shear force which is at the section X from the right hand side portion, so it is nothing but as per the definition of the shear force, it is nothing but the algebraic sum of all the forces towards left or right side of the section. So here the total number of forces which is in the beam is only W is acting. So W is acting from the right hand side, W is acting in the downward direction. So as per our sign convention, so right side support with the downward force is considered to be as the positive shear force. So therefore the shear force at section X is considered to be as plus W. So you can just observe that the shear force will be constant at all the section of the cantilever beam between A and B because there is no load between A and B. Means, so as we know that the algebraic sum of all the forces towards left side or right side of the section is nothing but the shear force. But as in this case of this cantilever beam, only one force is existing, that is W. So therefore the value of shear force at all the points of this cantilever beam remains constant, that is plus W itself. So that is nothing but the shear force at B is also equal to plus W and at X is nothing but plus W and A is also equal to plus W. Why is this? Because only one force is acting throughout the beam. Therefore the shear force will remain constant. So this is all regarding the concept of shear force calculation as in case of cantilever beam when it is subjected to concentrated load at the free end. Now coming on to the bending moment calculation. So bending moment calculation at section X we need to calculate. So here by considering the right hand side portion of the section X, so at the right hand side portion we have the force as W in the downward direction with a perpendicular distance of X. So therefore the bending moment is nothing but the algebraic sum of all the moments either towards left or right side, but here only one moment is acting. So therefore the bending moment at X at the section X at the right hand from the right hand side portion is nothing but force is W and perpendicular distance is X. So therefore it is equal to W into X, so which is acting in which is acting in clockwise direction, that is go along the force through the line of action, go along the force through the line of action, it is the clockwise direction. So therefore, as per our sign convention, if we are going from right hand portion of the section, if the moment, if we get it as in the clockwise direction, then the bending moment will be considered to be as negative. So therefore, w into x is considered to be as minus w into x, that is right side portion of the section with clockwise moment is considered to be as negative. So this concept is very nicely explained in my previous lecture series. You can just refer to that. So next, if I want to find out the bending moment at any section proportional to the distance, that is it is nothing but it is proportional to the distance of the section from the free end. So that is nothing but, if I want to find out the bending moment at position B, so at position B the bending moment is nothing but w into x is a general expression, but at position B the value of x is equal to 0. So therefore bending moment is nothing but w into 0, which is nothing but 0. So next is finding the bending moment at point A. So at point A the x value is equal to L. So therefore w into L, therefore it is equal to w into L. So at position A. So this is how to calculate the bending moment for the cantilever beam as in case of concentrated load at the free end. Now coming on to drawing the shear force and bending moment. So we need to first draw, as in case of shear force diagram, we need to first draw the baseline. So as we noticed that the shear force at all the points is same, so therefore the diagram will remain constant. So shear force variation for a concentrated load is in the form of stepped nature. So therefore the positive values are plotted above the baseline and negative values are plotted below the baseline. So here the positive of W magnitude is constant throughout. So therefore it is a rectangular variation or it is a stepped variation. So next, coming on to the bending moment diagram. So first draw the baseline, and then for a bending, when a beam it is subjected to the concentrated load, the bending moment variation is linear. So the bending moment variation is linear as in case of the beam when it is subjected to the concentrated load. So the positive values are plotted above the baseline, negative values are plotted below the baseline. So exactly at point B the bending moment is equal to 0, therefore it is exactly drawn on the baseline, and at point X it is W into X, which is the negative value, hence it is drawn below the baseline, and then exactly at point B it is negative value of W into L, so which is drawn below the baseline. So we need to join all this line by a straight line. Why? Because the variation as in case of the bending moment when the beam is subjected to concentrated load is linear. Thank you for watching. Please like, share and subscribe the video. Thank you.